online STTP on Tableau, data visualization tool for researchers. The first session will be on data connection in Tableau. I have the distinct pleasure of introducing our resource person, Mr. Sudharshan Mananathan, Senior Engineer, Oracle Fusion Middleware at L&T Infotech. He is an analytical techie with proficient knowledge in resource, finance, project analysis, and planning. He is also a design thinker to innovate the new prototype from legacy system and technologies. He is a certified analyst in business management and process management. He is a passionate in statistical analytics and algorithms. He has received the Star Performer Award for his and flawless resolutions. Also, he has been recognized for his proactive innovation by L&T Infotech. Thank you so much for joining us today, sir. I would like to request our resource person, Mr. Sudharshan, to take over the session. It's over to you, sir.
Thank you, sir. Good morning to all. This is Sudarshan from L&T Infotech. So, can I share my screen now?
Yes, sir.
Is my voice audible now?
Yes, sir. It is audible.
Oh, someone has pinged it as low.
No, sir. Now it's very clear.
Okay, fine. Thank you. Okay, so this is not the first session. I may not give much introduction about Tableau. I'll just give a beneficial overview alone. You all know, what is Tableau? Tableau is basically it is a reporting tool. It has an additional advantages of doing some basic level of not basic, maybe up to some intermediate level of visualization, data analytics, and some other things like intelligence activities. And it gives us enormous features and options to do graphs, then creating a calculated fields. We can do some good enough amount of calculations like statistics calculation, mean, median, average, running average, total, whatever it may be, percentage, etc. Most of the basic and intermediate level of mathematical operations it supports. Then it gives an option to give a wonderful visualized data. Okay, before going that, let me say a bit information about me. Who am I? Myself, Sudarshan Mananathan, who's having a 5 years of industrial experience, and I have worked in both open as well as closed integration technologies. Open in the sense freeware softwares and technologies. Closed is which are being paid technologies like Oracle technologies. So those things are also have worked. My major area is integrating both open as well as these closed technologies. Then I have worked in Oracle Cloud, IoT technologies, chatbot technologies. I'm also doing freelancing in Tableau dashboard making for industrial people, and also doing as a story designing. Then also I have advised few set of people college students in doing some projects in national level and those things and all. Okay. Okay, fine. Now let us come to the content. This is all about data visualization, data analysis, and data intelligence. Something like we are going to work with data. So it's mandatory thing we need to know what is meaning for data. Data, then what is the way of doing analysis, and what is the way of doing good visualization? I mean, to say based on the requirement of the audience, based on the requirement of a client, maybe client is in the sense from our perspective, we used to call our target audience as client, because those people will have their own requirement based on which we need to give a visualized graph or report or whatever it may be, because based on that report they'll be taking good enough decisions. Okay, so like after doing these are the basic terminologies, like then I mean from high level view, then like what are the ways of handling data visualization, then what are the essential principles in data visualization, then what are the I mean essential principles in the sense like while preparing a visualization you need to apply few basic principles. Say like everybody can do visualization, but that visualization should be like a meaningful one. Like a kid can draw an apple, but artists also can draw an apple, but apple should be looking like an apple. That is a way like how the data analysts and data visualization engineers view. Then types of data sources, like there are different types of data sources. Say cloud data source, then data or I mean, on-premises database data, then files of file data. Say for example like Excel, JSON, TXT, those things and all. Then what are the modes of data creativity? How, which are what are the ways in which you can connect to a data, like a live and extract. Then comes features of data connectivity with respect to Tableau products. Tableau products, then and there will be looking into like how a user can be given permission to add data, sorry, add data into the visualization graph. Then data connectivity from roles and administration perspective. Here we'll get to know like how the data, I mean Tableau administrator will assign a user with a particular privileges. Then data preparation process. This data preparation process is like how you will um, mean to say like how you can prepare the data from the data source, because the data which we are going to get is not a proper data. It will be in a random way. We need to order them and then we have to process them, and then only we'll get a data in a proper manner so that we can do whatever things we need to do, like some operations, and then we need to put into the plate, like from where it can be visualized in a better way. Then extract transform loop, and this is simple, like extracting the data from data source. Transformation means like how we are going to process the data which you have extracted from the data source, and how you are loading, I mean how you are going to load them into the graph or a chart or a map, whatever it is. And we are also look into few basics of like SQL joins, like I mean joins is nothing but a combination of two tables using a key. Key in the sense like a key is a particular tuple or a variable, not a variable, maybe a metadata. Based on that, we will be comparing two tables, those things and all we are going to look into. Okay, fine. Now let us go one by one. What is a data? Data is nothing but carrier of information. Say for example, if I'm speaking here, which means I'm giving a data for you all. This is also data. So data is like omnipresent. It exists everywhere. Like say if you're going to a shop, you're going to buy something, there are some things being entered in the computer, which is nothing but the data. And you're going to a school, your mark sheet, your attendance, your assessment, all those things are going to be entered in the computer, which is also nothing but the data. Each and every data needs to be analyzed by a respective people so that they can take some decisions. Say like the school mark sheets are being assessed by the teacher so that they can understand like how the student should be improved in a further way. Like the shopkeeper will analyze the data and he will get to know like which brands of groceries are being purchased by or being preferred by the customers a lot, so that he will more kind of and those things are so data is nothing but information. Raw information is called, it can also be called as data. And right now it's like in the field of artificial intelligence, deep learning, machine learning, human computer interaction, everywhere data has become omnipresent, especially in terms of IoT and those things and all. Like for each and every second, the data streaming is increasing a lot. Like for every second, such amount of data is being read by the sensors and actuators, and they are being given to the database system. Based on those data scientists, data analysis, they used to do some analysis and they will take a necessary action, and that's how it goes on. I mean, that is how the industry is evolved. Then hyper exponential. Earlier, not we can just consider this normal SD card and those things as an example. Earlier, the data was very less, and the storage device was very big. Time goes on, like the data has become a lot, so they have decided to reduce the size of, I mean, physical hardware, and based on this, now a normal computer itself had to have like 1 TB data, 1 TB hard disk, those things and all. So like the data accumulation has, I mean, increased a lot. Then half our acquisition of ability to handle data, and we could have come across many advertisements or any something like that in FB, I mean Facebook, or in YouTube, Twitter, whatever it may be. Like the need for more data science engineers and data analysts are required in India right now. Maybe like 150,000 jobs in 2020, 21, or 22, something like that. It is being estimated minimum 150,000 jobs are there for a data scientist and data analyst. Maybe much more than that. Depends upon the scenario and depends upon the timeline. While analyzing the data, like whoever it may be, there are only four ways in which the data can be analyzed. Like dimensional analysis. What does it mean by dimensional analysis? Dimensional analysis is like viewing the data from one perspective. Like say for example, in a company from a logistics division, there is a manager like who cross-check after the receipts payment made during every quarter. His task is like whether, I mean, his task is like to check whether the payments being made are properly done or not, whether is there any payment due, or he need to look into those things about. His dimension is like only to view those kind of things. He'll be looking only into towards data towards this auditing, payments, accounts, etc. So to do an analysis. Say for example, the company might have a different levels of people, like a top management team who are totally belong towards a decision making process, and then comes the manager team who coordinates and supervises what's happening and what happen in the future, those things and all. Then then comes the next level, like maybe supervisors, then department head, those people and all. Then comes not lower level, it's very bad to say like that, maybe core employees of the company. I mean, based on their cadre, they will be having a different perspective on data. So similarly, like a manager, from his perspective, he will just cross-check out the receipts payments during every year. This is called a dimension. I mean, to say like we'll be viewing the data in one dimension. The entire data of the company might be from could be from various dimensions, like accounts data, then HR details data, then comes transports and logistics data, whatever it may be. These kind of data will be there. All these data will be clubbed together, and the manager's role is like they need to visualize. I mean, they want only the data from this expense receipt. In that case, like we need to give them only the report which they required. That is our task. So we'll be working in such a way that we will consider ourselves as in the place of the manager, and we'll be getting the data from his dimension. That is called dimension analysis. Then comes contextual analysis. Contextual analysis is like analyzing the data for one particular purpose. Say for example, like I'm not sure whether it has happened in India or not, but in few countries like European and North American countries, it has happened. Like during every particular time and travel, they will be analyzing the data of the traffic, and they will regulate the routes accordingly. So this is like a contextual analysis, like a purpose oriented. So here simple, like a context is nothing but a purpose. The analyst will be analyzing the data for a particular purpose. That is called contextual analysis. Then comes, in contextual analysis, like government will take decision in case the traffic is very high, then they will propose for alternate traffic plans, like construction of flyovers, subways, underpass, whatever it may be. Those kind of analysis is called contextual analysis. Then comes physical analysis and calculative analysis. And physical analysis. Okay, right. And also I would like to say, like, first two types of analysis are non-technical. I mean, it does not directly involve into data. Then last two are technical analysis. Like physical analysis is a kind of analysis where we'll be involved with real-time data. Since raw data expects to have fluctuations, fine. I told like analysis is like it's not a straightforward process. We'll be getting a large amount of data, and we need to find like what is the need of the data, like how this data is going to impact the solution, whatever it may be. Like, and of course, this data are expect to have some fluctuations. Fluctuations is like say, in part comparison with the signal. In signal, we'll be removing those noises and those things, right? Similarly, here in data, we need to remove the noises. Noises in the sense like unwanted data. As I told, like we'll be getting the lots of, say for example, if I want to find the data for weather forecasting, I need data only for this entire week. Then how will I get the data? I'll be getting a large amount of data, like what is the sensor value, what is the actuator, what is the humidity value, those things. And based on this data, I need to first processes, like I need to set a timeline from which data to which data I need. Then what's the details obtained from those sensors and database, whatever it may be, like the data from the data source. Then I need to remove the unwanted data. And this unwanted data after removing those unwanted data, we'll be getting a clear data, which is the actual data. This is called the physical analysis. Physical analysis is like working onto the real-time data, like removing those fluctuations, and those things are all called. And in physical analysis, we'll be doing some low-level mathematical operations, statistical operations, those things. Then comes calculative analysis. This calculative analysis is truly for statistics and statistics and accounts people. Like they'll be handling numbers in terms of some mathematical operations using some algorithms and those things. Like a data analyst and data science people will be procuring the data, and they will be doing some algorithmic operations, and they'll be doing some kind of activities like that. Those things are called as like a calculative analysis. Then why do we go for Tableau? Like we can ask why Tableau, what can be done in Tableau, when Tableau should be used, where Tableau can be applied, and how Tableau can be used. These are the questions. Question in the sense like in order to justify the usage of Tableau. Yes, obviously Tableau is right now for front runner in data visualization, data reporting, and even parts of data analysis and intelligence too. Like we can do lots and lots of integration kind of activities. Like we can connect with all the prominent database that exist in the world right now. Like it may be open source, or it may be paid software, maybe like Oracle SQL database and Python, PostgreSQL, MongoDB. Not Python, maybe MongoDB, etc. Whatever it may be. It also connect with cloud services like Google, AWS, Azure, many things like that. And also, like this is the biggest advantage. Like it doesn't have a limit for data. Like if you connect with Tableau or an online or Tableau server, then you can expose an enormous amount of data without any limitation. Then who can use database? Who can use Tableau? Anybody can use Tableau. It doesn't require any programming knowledge or something like that. It is very simple to use. And with respect to cost benefit also, like Tableau is not going to be very costly. Like for a organization, mid-level organization, Tableau is actually compared to say like, more than a large organization, Tableau is very much suited for mid-level organization because like they can use with a single user or a two one or two users in order to generate a report, and those reports can help the company to analyze their workflow or operations, whatever it may be. Then, what is the need for visualization? Mm, to be fact, I don't like numbers because reading the numbers and understanding it and doing some calculations on that is not so easy for me from my perspective, which made me to make some graphs so that which with the graph I can analyze. Like I used to calculate like how much I'm spending for for an expense every month, maybe for a transport expense or for fuel expenses for my bike or for my car. In that case, like I'll be analyzing like in this month how much I have spent, in this month I mean how much I have spent, like so that I can analyze like whether it is increasing or it is decreasing, or like in which cases it is increasing, those things and all, like I can analyze with the data alone. Like it will be a tedious process for us because in my case fuel cost is not a very big amount of data, but for a company like I mean, say for example like Ola, Uber, those things and all, the data will be like large. In that case, they can't do calculations with each and every numbers. In that case, they need to take decisions with these kind of visualization, graphs or charts or reports, and that is the need for this visualization. And also, like even the analyst can also rely on this visualization because, say for example, a genetical engineer will do an authentication combination. All those data will be stored in this. If all those data were stored or exhibited as a report, then it will be more beneficial for him to analyze like what's happening in that process or that level testing, what is happening, which he is doing. Then, what is a way to handle data visualization? Like the first and the foremost task is like we need to identify the target domain or people or the requirement. Domain as well as people as well as the requirement. Like what is a domain in which we are doing, in which we are going to do data analysis? It is like inter-domain or intra-domain. Inter-domain means between two domains. Like mm, let us take an example of government of India's data. Like there could be many domains. Like say for example, one is like industrial development. Industrial development domain might be having a lots and lots of data. Similarly, on the other hand, the government will also have data for this skills development for students. Both are under two, I mean, same ministry, like a human resource development ministry, but these two are two different domains. One is for improvement of industries and standards in India, and one is for like developing skills. And we need to identify like for this domain what kind of data should be given. I mean, visualization should be given, and for another domain like what kind of data should be given, that we need to decide. Then comes people. So as I said, there are two. I mean, the about two cases. Like one belongs to students, employees, and those things like skills development domain, and the other case belongs to industrial aspects. Maybe some entrepreneurs will be having those data. I mean, they might need the data. Then then comes the requirement. Requirement is like we can give the data like these are the technologies that are going to be boom in next for next 5 to 10 years. So let them be skilled with those technologies, and they might be having, they might get some information from us. This is the requirement. Like which technologies are going to be in the boom for next 5 to 10 years. I would like to learn that. If they ask such question, then we need to answer them. These are the technologies that is going to be boom. And similarly, what does the other people ask? I mean, industry development people. For industry development people, like what are the incentives available from the government? What are the tax explosions? possibilities and those things are not like what is the tax that are being paid by by that company to the country, those things and all the requirement from them. Then comes gather and analysis data source. First one is like from the layman's point of view, like it is a non-technical thing. Then comes gather and analysis data source. In the second one, like we'll be slightly moving towards technically. In this gather and analysis data source nature. Nature like what is the nature of the data source? The nature of the data source could be discrete or continuous. What's discrete data source? Discrete data source is like part by part. I mean, data is available for one particular time. For another particular time, there might be no data, and again for another particular time, there might be data. Like asynchronous. It is not like a synchronous data. While other kind of data is continuous data, which is nothing but a synchronous data. We'll be having data continuously for at any point of time. We'll be having data. So we need to analyze like if the data is discrete or if the data is like continuous, how it should be processed. That we need to think and decide based on this data source nature. Then comes the frame, the timeline of the data source which needs to be visualized. Now, like what is the timeline in which the data should be processed? Say, for example, if I want to find the data for, if you want to analyze the data for last 5 years, in that case, like how I should do. Excuse me, can you please wait for some time? I'll be back in another 1 minute. Okay, like frame the timeline of the data source which needs to be visualized. We might be having data starting from the beginning, but we need to process the data like between those particular span of time. Say for example, if the company wants to check what is the performance of them like between a particular span of time, maybe within 3 years. In that case, we need to remove all the data prior to those 3 years, and then we need to look like these are the things which has been done and which have been done in that particular 3 years of time. Then enjoy.
Participants, please wait for some time.
Hello, hello. Am I audible now?
We can hear you now, sir. We can hear you.
Okay. Okay. Sorry, this is network issue. Okay, fine. Now, I don't know like when it got disconnected. Okay, let me continue from engineering flexibility in visualization. Like the major aspect of visualization is like a data should not be a rigid one. Like we need to have some flexibilities. Like normally, if you do some kind of visualization in Excel, you can't do some changes in the graph in the runtime. But in Tableau, you can do that. How we can do that means like we have some options like a filters and those things and all. using those filters, we can filter the data in the random type. And it also has given an option called a text box where you can enter the data and those things and all. Then ensuring individuality of each and every data in visualized content. What does this means? Like we might be having enormous amount of data, but each and every data is very important. Like there might be many parts in automobile vehicle, but each and every part, each and every screw is very important. Similarly, like we can give a visualization, but each and every data should be a visible thing for a person, for a client. So in that case, like we can use options like a label, a text, and those things and all. Like we can insist on each and every data. That is called like we need to project each and every data like importance in the graph. Okay. Now, what is the data connectivity process? Data connectivity, like you can say like live in data and extract data. How can you? What are the ways in which the data can be connected to a Tableau? I can show you an example. Let me tell you. I'm going to run a program. I mean, a Python program that is going to give a data set for me. If you want to see that program, you can see here. This program has given me some 30,000 rows of data. If you ask me like what is this data is all about, and in this particular city, what are the different types of vehicles that has passed through on which date, and which state those vehicles belongs to. These are all the data which we are going to analyze now. So right now we have got some 30,000 rows of data. And I'm going to push this into Tableau now. Let me push that. So now it has loaded. Okay. So now let me take.
Or RPS sample. One of the model. I tell you, once I go to the random forest model, I will tell you the importance of kernel approximation. The next, I also want to impose. Sir, your voice is breaking down, sir.
No, someone is speaking in the middle. Hello. Hello.
It's clear now, sir.
No, okay, fine. So now, like, let me check. Let me create a calculated field. Like, I want to know like how many vehicles has crossed in that span of time. So fine. Now let me again run the script. Let me make it now 50,000 rows. Now I'll be getting 50,000 rows. Okay. Let me refresh the data now. See, can you all see the changes now? This is called like live in data. Whatever the data that are coming into the database will automatically get reflected. And for this, we can also create some jobs or schedulers in admin, level. Like similar to database administrator, there is a position called as a Tableau administrator. And those Tableau administrators will create a schedulers, jobs, and actually those people will be maintaining the assets of a worksheet or a dashboard, whatever it may be. And those people will be creating the schedulers, which in turn run during a particular span of time. I think if any of you would have got information about this Windows scheduler in a Windows machine, and as well as this cron tab in a Linux machine, similar to those things, we can also create a schedulers kind of thing, and this schedulers will in turn run these details in the backend. And as soon as the data is getting accumulated, the data refresh will happen in the Tableau automatically or immediately. This is the kind of data connectivity. Like then comes extract data. What is extract data? Actually, whenever you work in a Tableau online or Tableau server, you will get an option so-called like how can you can have a feasibility of storing the data in your local machine. Say like if you're working, say in our case, like doing work from home. In that case, I don't have access to cloud machine outside office network. I don't have access to client's data outside office network. Then how can I do? I'll just extract the data from my client's machine and then I can use it in my local machine. And in that case, if I do any changes in that in my machine, the Tableau will respond only with respect to my machine's data, and it will not have information about whatever the data that are being changed in the client's machine will not get imported here. In that case, I can't use this extract. I'll be just working with this extracted data. I think you would have got information, got difference between both live in data and extract data. Live in data is like all the string data will come to Tableau, while in extract data, those string data will not come to Tableau. We need to pull them manually. So till now, do you have any doubt? Hello. 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 No, no. Is there any doubt for anyone till now?
Yes, sir.
Is there any doubt
Hello.
for
Yes,
anyone?
sir.
Hello. Yes, ma'am. Do you have any doubt?
Participants, if you have any queries, you can raise now.
I have a doubt, sir.
Yes, sir.
Sir, how we can do a data in live or extract? If I have a data, I put it from the Google and in a Microsoft Excel and then put it in a Tableau. And then I click on the live button over Tableau. What will it
Okay.
happen? Can you tell me the exact difference between live and extract?
Yes, sir. Like before that, I would like to know how you are pulling the data. You are getting the data from Google and you're putting it into Excel file, and
Yes,
that
sir.
Excel
Yes,
file
sir.
data is being populated into Tableau, right?
Yes, sir.
Okay, fine. Just answer my question. Like, how are you getting the data continuously from Google to Excel? Are you running any program for that or something like
Yes,
that?
sir. I am putting a data of like COVID, but I can't put it matlab, continuously. I have to download it from Google. How I can live it? Just not
From
put it from
Google,
Google.
like, wait. From Google, which are you getting it from any JSON data or something like that?
No, no, no. I just simple data from Microsoft Excel of COVID-19 from this to this date. But I want to be alive that I don't should to be downloaded
Wait,
every day.
one question. You are getting a data that is Excel data itself from Google, right?
Yes, 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 sir.
If you get Excel data itself from a Google, there is no continuity between your data, I mean, your Excel sheet and Google.
How can I
It will
do
be,
it live?
you can, whatever the data which you're going to save in the Excel sheet can be given as a live data. But here in this case, which it's something like you need to pull the data from Google manually.
Okay, okay, sir. Okay, sir.
Anyone else? Hello.
Participants, if you have any more queries, you can ask now.
To the person who asked me the question, like how can they get the data manually from, I mean, continuously from Google Meet, they can go for Selenium. Selenium is a good option, like from which you can download the data continuously. I don't know who is the person who
Sir, from
asked me this.
where?
From if you want to get the data directly from Google, then you can get the option of Selenium. In Selenium, you can download that data continuously into this Excel sheet. And this Excel sheet parallelly you can connect with Tableau. That's a good option,
Can you
and it's a
name
doable
it,
thing.
sir, in chat?
Selenium is nothing but a Java framework which is being used for testing purpose.
Oh,
I'll think that I'll type the name of name of the software. Selenium.
okay, sir. Thank you. Thank you, sir.
Okay.
So thank you for excellent presentation on data connection and tab.